In today's video, we're going to be taking a look at MultiConnect's mDot box. The MultiConnect mDot box is a portable, handheld LoRa endpoint device that simplifies and speeds up proof of concept and development, which is ideal for surveys designed to help companies quickly determine if LoRa is right technology to solve their industrial IoT issues. The mDot box helps companies determine if their LoRa-based IoT applications solve the questions by making it easy to obtain real-world LoRa performance information through the site surveys or proof of concept development results. With the click of a button, the mDot box provides a wealth of valuable information such as location, spreading factor, throughput, time and date activity, and power level usage at the very locations companies are planning to deploy LoRa technology. Viewing and analyzing the site survey data is easy thanks to the versatility of the mDot box, which provides multiple ways of exporting the data. The mDot box features a LCD display menu and has two push-button controls that are also included, providing menu navigation functions and two LEDs for displaying network and GPS status. The mDot box also has several built-in sensors, including temperature, ambient light, pressure, and a 3-axis accelerometer. It comes standard with GPS to enable site survey and location-based proof-of-concept testing. This versatile device can be used purely as a communications device or be programmed with custom application using the integrated ARM embed-enabled programmable MultiConnect mDot. The mDot box provides 3 modes to make it easier to evaluate LoRa technology use cases. The first mode is a LoRa demo mode, which is ideal for testing IoT application prototypes and proof of concepts. In this mode, sensor data is transmitted to the LoRa gateway at user-defined intervals or just by the push of a button. There's also a survey single mode that tests connectivity with LoRa gateway at different data rates and power combinations. The third function is a site survey sweep mode that tests connectivity with the LoRa gateway over a wide range of data rates and power levels automatically. Following the LoRa Alliance plan to ensure openness and interoperability, the mDot box was developed to work with LoRaWAN compliant gateways, including MultiTech's MultiConnect conduit, the industry's most configurable, manageable, and scalable communications gateway. It's easy to use, customize, and manage. The mDot box makes evaluating LoRa technology for IoT applications as easy as clicking a button. The mDot box does come with a 9-volt battery, so it is battery powered. And as you can see, it has an external antenna. The mDot box does come with default credentials. There's a app ID and a passphrase that need to be entered, as well as a frequency subband. So the mDot box defaults to a frequency subband of 1, and then the ID and passphrase are both MultiTech, capital M, capital T. So there's no configuration necessary on the mDot box when you get it brand new. All you'd have to do is configure your gateway settings to match the mDot box. So let's do that. So I'm going to log into my gateway. And this happens to be the AEP version, which is MultiTech's Application Enablement Platform, which is GUI based. But under the setup option and the LoRa network server, I'm going to set the frequency subband to 1, and I'm going to set the network ID to MultiTech and the network key to MultiTech. And typically I would just submit that. And in this case, even if there were changes to submit, it does not require a reboot of the device. Because this gateway uses IBM's Node-RED, which is a graphical developer environment, first thing I want to do is put in a flow that can decipher the LoRa sensor data. So the first test, we're going to send the LoRa sensor data from the mDot box to the gateway. And then it'll be through a Node-RED flow that we're able to visualize that data. So here I have a WordPad document that has the code in it that I need. So I'm just going to select all. I'm going to copy it. At this point I can close this and then bring my browser back up. And under Apps, I'm going to right click on Node-RED and actually open this in a new tab. So I'm going to open the Node-RED programming environment. And once I'm in, you can see that I have a blank canvas. But there are input nodes, output nodes, and function nodes. And basically you can build a flow using Node.js and JavaScript. But over here I'm going to click on this icon and I'm going to want to import a flow through the clipboard. And once I'm there, I'm just going to do a Control-V to paste what I had copied earlier and just say OK. So this basically gives me a function node, and the function node does have JavaScript code in it that's going to parse out the sensor data information. So what I need in addition to that is going to be my LoRa input node, and then also just a debug node, my debug output. Once I do that, I'll connect these together. And I'll deploy that. And I'll confirm the deploy. And then I'll just select the debug option here, because now I'll be able to view any data that comes in to my LoRa gateway and will be processed by the function node and then displayed on the debug tab through this message payload tab. Okay, so now I'm going to turn on the MultiTech dot box. And the first thing you'll notice is it does give you a menu. And I guess a introduction splash screen, and then it gives you a menu. And you have a scroll button, which is switch 2, and a select button, which is switch 1. So I can use switch 2 to scroll through the different functionalities of the device, which is LoRa demo. We have a configuration mode, a survey single, and then a survey sweep. So for right now, we want to select the LoRa demo, and I'll select that. And the MultiTech dot box is going to try and join the gateway, which it just did successfully. And now it asks me, do you want to send the sensor data at an interval, like every 15 seconds, for example, or do you want to do it on a trigger with the press of a button? So I'll select the trigger mode with the press of a button. So now I can see that my sensor data is being displayed on the LCD screen. And with the touch of switch 1, it will send that data to the gateway. It should be processed by the Node-RED flow and then displayed on my debug tab. So I'll go ahead and I'll press switch 1. And actually, let me modify my LoRa node by double-clicking and changing the format to bytes. And let me deploy that. And I'm also going to send more sensor data. And then on my debug node, instead of the message property, we're going to select the complete message object and say OK. And we will deploy that and confirm the deploy. Again, I'll send the sensor data. And now we see that we have valid readable data on the debug tab. We can see the temperature is 24.4 degrees Celsius. We see X, Y, and Z axis. We see the Z axis at a 0.8, which is close to 1 G force. We see the barometric pressure. We see lux, or luminosity, which is a measurement of light. And those are that is the sensor information. Commonly from here, once the sensor data is sent and received on the gateway, it's typically pushed to a back-end server or to a cloud platform. And that can also be done with these Node-RED input, output, and function nodes. So here I'll send the sensor data again. Now if I just hold switch 1 in, that will reset the device and bring it back to the main menu. So I did that. That took us out of the LoRa demo mode. So next we're going to be looking at the LoRa surveys modes. And there's a single survey sweep and a multiple survey sweep. So as I use the scroll button, I'm going to scroll down to a survey single, which is the single survey sweep, and I'll select that. Once I select that, it does a join process with the gateway again. And at this point, it's saying, do you want to erase or append? And so I can erase any previous survey data that's stored on the device, or I can just append this survey data to what's already on the data file. So I'll select append. And now I have the option to do the survey by hitting switch 2, or I can change the data rate and power level. So the data rate is at 7 and the power level is 2, which is a very low power level, 2 dB. And the data rate is 7, which gives it the shortest on-air time, and for actually the least amount of range. So when I hit the survey button, it says the survey is in progress. Survey did pass, and I basically get a margin of 19, and then also I get decibel level down and signal to noise ratio. And because I'm in very close proximity to the gateway, the values, I guess actually, I get a minus 20 dBm down, which is a downlink, which is a very strong signal, and also a signal to noise ratio of 6, which is very high on the positive end, which is very good. And I have a margin of 19, and this is margin of dB, in dBs to the demodulation floor. So in many cases, LoRa can operate below the noise floor, and but it's the demodulation floor. Once the margin goes to 0, basically we cannot get data through. I could change the data rate and the power setting and do another single sweep. And this data is now stored on the MultiTech dot box. So I'm just going to hold switch 1 in to reset the box. And now I'm going to use switch 2 to scroll down to a survey sweep. I can also do a full survey sweep now. This will cycle between 4 power levels and 4 different spreading factors, basically through a range of the power range and spreading factors of the box. And it's to help give a good RF picture wherever you're doing this survey, across multiple power levels and multiple spreading factors. So when you do a 16-point survey, because it's 4 different power levels and 4 different spreading factors, so there are actually 16 separate surveys that are done as part of the sweep. So it's common that you'll see a few failures, particularly at the low power levels of 2 and the lower spreading factors. So the higher the spreading factor or data rate, the more redundant information is sent, and it equals longer range, but it's longer on-air time and could be a shorter payload. So there's a trade-off for the long range. But that's just kind of an explanation of the different, when you do a full survey sweep, and a 16-point survey is going across several different power levels and several different spreading factors. So for that, which the data is also stored in the dot box, but the dot box can be configured to also send that data to the gateway. And there's also a flow we make available on our device HQ, which is like an app store, a flow that you can load onto your conduit AEP, if you have the AEP version of the conduit. So to do that, I'll have to delete this existing flow and load a new one. So to do that, I'll just kind of highlight the flow and hit delete. I'll deploy that. I'll confirm the deploy. And now I want to open another, there we go, .box Google, edit. Select all, edit. We'll copy this flow. I'll go ahead and close it. I'll bring up Node-RED again. But here, this is a valid flow, so now I can say OK, and I can deploy the flow. So this flow will take the site survey data, and it will store it to the SD memory card of the conduit gateway in a comma-separated value format so that you can import it into a Excel spreadsheet. And if used outside where the GPS can get a lock or a fix, it will also push the GPS data, and we can display that on Google Maps in real time. So today we'll go ahead and we will do a site survey. So I got the survey sweep selected, and I'm going to select it. It's going to join the network. I have a success. It asks me if I want to erase the file or append it. I will append this to the additional sweeps we've done that's stored on the dot box. And then I'll ask it to do the sweep by hitting switch 2. And it's going to do a 16-point survey sweep. And as these sweeps happen now, we can see the data coming into the Node-RED flow, which will be stored on the dot box. So a full 16-point survey could take up to a minute, minute and a half to complete. Because it is cycling, it starts at the lower power level and cycles through the different spreading factors and then goes to the next power level, all the way up till we get to a 20 dB power level, which is the maximum power this device can transmit at. But so far we're on 12 out of 16. And I do have, looks like 1 failure and 12 pass. So I got just a couple sweeps left here to complete the survey sweep. There it is, 16 out of 16, and pass 15, fail 1. All this will show up on the LCD screen. But the next thing I'd like to show is how do you get the survey data off the mDot box. And to do that, you would need a developer board, whether it's a micro developer board or the standard LoRa mDot developer board that I have here. And you'll need this ribbon cable that comes with the dot box. So typically what you would do is connect the ribbon cable to the dot box. And the dot box does have a header pin over here to connect this cable to. And next I'll plug the developer board into my PC. So basically this is going to enumerate a port now. And on the dot box has a menu, and I'm going to use switch 2 to scroll to configuration. And then I'll go ahead and use switch 1 to select the configuration mode. So like I say, it did enumerate a COM port, so I'm going to use a terminal emulation program like TerraTerm to communicate with it. So I'll bring up TerraTerm, and I need to talk to it at 115,200. There. If I do AT and enter, I get an OK, and I am talking to it. AT ampersand V or Victor. AT ampersand V will list out its current settings. But to get the survey data file, it's AT plus GSDF, get survey data file. So there you can see the survey data file in the unit. AT plus get survey data file. And if you look across the top, there's an ID, a status, a lock, latitude, longitude, altitude, time, number of gateways, margin, RSSI down, or receive signal strength indicator, signal to noise ratio down, data rate, and power. So as you look at the ID, S1 is survey 1, and S2 is survey 2. L1 is a single point survey, and then S3 would be survey 3. The status is a success or a failure. So if we look at survey 3, we can see that the first survey failed with an F, where the rest were successful. The 0 indicates that there's no GPS lock. And then the other commas indicate that there's no GPS data, and that's because I am indoors. Number of gateways, so which is 1 down the line. This is the number of gateways that the mDot box has visibility to. But then we get to margin, and the margin here is pretty consistent up at 19 and 20, and this is margin above the demodulation floor. In the site surveys, or any of the surveys, I feel this is the most important parameter because when margin goes to 0, you cannot get any data through, you will get a failure. But as long as the margin is 1 or more, generally your surveys will be successful. So in addition to the margin, we also have the received signal strength down. And in this case here you see it's 18, 17, 19. That is a negative number, but because it is known to be a negative number, we don't add the minus in front of it. But this is the received signal strength from the gateway, so it's from the viewpoint of the dot box. There's also the signal-to-noise ratio, and you can see here it's 5.7, 6.7, 6.5, 7.0. We have a very high signal-to-noise ratio, which is good. The higher the positive number, the better. As we get below the noise floor, but are still able to communicate, you might see the signal-to-noise ratio take on a negative value, like -2 or something. And then you also see the data rate and the power setting. So the data rate here was 7, and the power setting is 2. So you can see as the survey goes on, it'll keep the same data rate, but cycle through the different power settings from 2 to 8 to 14 to 20. And then the data rate changes to the next data rate, which is 8, and then tries again at the different power levels, 2, 8, 14, and 20, and so forth. So it goes through a full 16-point sweep. So you could easily copy this information, I guess everything but the command. You could copy that into a, we'll say a Word document or Notepad, some type of, you could copy it into Notepad, and then you could use an Excel spreadsheet, and you could use Excel and create a comma-separated spreadsheet with this information. So if you were able to load this flow and get the information on an SD card, memory card, how would you get at that information? So I would use FileZilla. Let's close that. Basically I have a quick connect. We're going to use SFTP. So basically I would use SFTP, SFTP admin at the IP address of the conduit gateway. So actually my host IP address is going to be 192.168.4.210. And the username is admin. The password is admin. Okay, so there we have it. And if I go to the root directory, you're able to see media, and then within media there's a card, and then on that card is the file, which is labeled EVB CSV. This is the data file that contains all the survey information that was sent to the conduit gateway if you had used that flow. So if you use this flow. So this flow does reside on MultiTech's Device HQ. Device HQ is like an app store for the conduit gateway where you can create well, you would create applications on the conduit, but you could upload them to the app store on Device HQ. And they could be private just for yourself, or they could be public and public for everybody to see. So here's where I would configure the device. And once you connect the ribbon cable to the dot in the box and to the developer board and plug the developer board in, typically you would power up the dot in the box first and then plug in the developer board. That's the procedure you need to follow. And then through the push buttons you'll set it for configuration mode. Now I've got a terminal emulation program open because this does enumerate a virtual COM port, and I configure it for that COM port at a speed of 115,200. 8, none, and 1. So from here I can type AT commands to program the dot in the box. And assuming you want to change the parameters to match the gateway, and they're not default. So you'd want to set the frequency subband and the network ID and network passphrase. So to set the frequency subband, you would use the command AT plus FSB equal, and I can set it now from, say, 1 to 7. So I'll hit enter. I'll use the command AT plus NI to set the network ID. AT plus NI equal 1 comma, and then like 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, I just set it to that. Next, I can modify the network passphrase with the command AT plus NK equal 1 comma 987654321. So the network passphrase has to be at least 8 characters, but it can be the same as a network ID, or it can be different. But these are used to generate keys, encryption keys. So now that I've set them, I can do an AT ampersand Victor to list it out, and then I could do a AT ampersand W to store it to non-volatile memory. And that's how you would get the, that's how you would program and configure the dot box. You could also just put a question mark and enter, and this will give you all the valid commands for the dot box. So these are the valid commands that you can use. So with that said, now you can modify the configuration settings in your dot box to join your own conduit, particularly if your conduit LoRa network server settings are different from default. So with that said, thanks for watching today's video. We have a great site survey tool that can do site survey information, and it does a 16-point survey or a single survey sweep. Those are 2 of the functions. The third function is this device has several sensors where it will send sensor data to the conduit gateway, which will allow developers to focus on how to visualize that sensor data and get it to the back-end cloud or back-end server. So thanks for watching, everybody.